Hello, my fellow defenders. Today I thought it would be a good idea to give you an overview of our free compromise assessment scanner called THOR Lite. I did this already for the German magazine Heise Security like 2 months ago for a German audience, and I thought that although we have a manual online and a description page, I think there are some parts of it that have to be explained. I guess this will be a longer session, so maybe I will cut it together in the end, but let's see. So I thought, how could I, what would be the best way to introduce to THOR or THOR Lite? I think, although I'm not the biggest fan of slides, I will just give you a few slides with the most important key points, and then show you how to get it, how to download it, and to run it with some usage examples, so that you can see how it is used. Okay. So first, I try to fit the slides here in that rectangle that I'm capturing the video. I hope that I hope this works. We'll see. Okay. So first I'd like to answer the question, what is THOR? It's not that easy to describe, but we say that THOR is a scanner that's designed to detect adversary activity on endpoints. So we classified it differently over the years. First we called it, I think it was just a triage tool, then we said it's an APT scanner. And today, if someone asks, we say that's a compromise assessment scanner, because compromise assessments it's a term that's already used in different organizations, and people understand why what it means. That wasn't the case in the past. So many marketing materials and pages still promote it as an APT scanner. So it's feature rich. You can use it for live forensics, for image scans in your lab. It also has a mode called drop zone mode that's not available in the free version. So I'll skip this. Also, Sigma scanning is not available in the free version, as well as remote scanning. But we will get to all the features of the free version soon. So it's flexible. You don't have to install it. It's not an agent, it's not software that you install on an end system. It's a portable tool. That's what it basically is, right? Standalone, but you can use it. That's what we sell at Nextone. You can use it in a managed way with the ASGARD system and ASGARD agents that you can use to schedule and run THOR scans. But the THOR Lite version can be used standalone. No internet connection needed, completely portable, and multi-platform. You can use it on Windows, Linux, and Mac OS. Only the standard version, the THOR version. Also, we also have a version for AIX. So, what is THOR designed to detect? That's what people often ask when we compare it with an antivirus or an EDR. Then I use this slide to explain more what we aim to detect and where our focus is. We are only 17 people now at Nextron, and we have 5 people working in research. And we focus all our research efforts on hack tools and APT group related activity. And not just on the malware or hack tools used, but also on the output of the hack tools. Traces that the usage of the hack tools leave on an end system. So THOR and THOR Lite are designed to detect things like the hack tools that get released every week, and we try to write and deploy rules for these new hack tools as soon as possible. So Mimikatz here is just an example, but in the past, Mimikatz and other password dumpers were not detected by antivirus solutions. They were classified as possible unwanted application, pure, and often out of scope. You could enable pure detection, pure scanning in antivirus solutions in the years 2012 to 2016 optionally. It was not enabled by default. But, well, it was available. Our customers at that time didn't use it, and therefore we use THOR in these cases to detect many of these hack tools in these years. But there are other anomalies or suspicious elements that THOR is designed to detect. So I often use this example here, example number 3, a renamed PSExec. Like, how common would you say is it that administrators rename a PSExec to p.exe and place it in the ctemp folder? That's something that happens not so often, and it could be an indication for malicious activity. That's why we have many of these signatures, YARA signatures, that you can find also in the public repository in a certain file, in which we use external variables like the file name, the file path, the extension, the type of the file based on some magic header checks. And then you can combine the content of a file with its name, with its location, with its extension. For example, you can say if the magic header of a file is that of a portable executable, and the extension is txt or JS or something else, you could write a rule for that and highlight this anomaly on end systems. As I said, we also write many rules for the output of hack tools, like something that stays behind when adversaries already remove their tools and implants from an end system. You sometimes find reconnaissance output of reconnaissance scripts left in temp folders of the system, like a system info, netstart information appended to a file, and then this gets copied by the adversaries to their remote system for analysis, but it stays on the system. So we have rules for that as well. Things like a LSASS memory dump. You can use pb dump or proc dump. Sorry, you can use proc dump, or just the right click in the graphical user interface. If an attacker is on that system via RDP, you can open up Task Manager and then right click on a certain process and create a memory dump of that process if he has the necessary rights to do that. And then you can exfiltrate that LSASS dump and use Mimikatz, for example, on your attacker system to extract credentials. Yeah, but the LSASS memory dump on disk would still be suspicious. That's something that an administrator shouldn't do, because the LSASS process memory dump contains credentials of all users on that system that have logged in and are still available in that process memory. So that's something that administrators shouldn't do, and we have rules and sometimes only file patterns that would detect an LSASS.zip .rar, for example, to highlight packed memory dumps of that process memory. And other system file anomalies, for example, if a Windows executable in the system32 folder is packed with UPX, that's something suspicious. Or files compressed to RARSFX, so the executable packer, and have a Microsoft copyright. These combinations of attributes, characteristics should trigger a suspicious event, and that's what we do with our scanner. So as I said, it's focused on adversary hacker activity, flexible deployment. You can use it on a USB drive, carry it to the target system, copy it over via RDP to the Exchange server of your choice. You could even place it on a network share and then run it on a target system via the UNC path. You don't have to copy it to the target system. It runs from that UNC path, like / server / share name / THOR 64.exe, and then you could run it right from that UNC path. We also have an impressive detection rate. So I will compare the THOR and THOR Lite scanner in a minute, but the detection rate, or what we mean with impressive, is that we are strong highlighting the things that an antivirus or an EDR misses. And that's something that we can do because we don't have to block or delete immediately like an antivirus. We can say that something isn't good and it isn't bad, but it's suspicious, and an analyst should look at it and decide if it's an incident or an anomaly, false positive. We have multiple output options. All these are available in THOR Lite, so you can output everything that THOR reports as syslog to a syslog server, to your SIEM system, UDP, TCP. I'm not sure if we have already deprecated CEF for ArcSight systems, but this could happen in the near future. It wasn't used so often. Most of our customers used TCP and UDP and the JSON outputs. Optional TLS. There is a text log written during the scan, so and an HTML report that gets generated at the end of the scan. You can include custom IOCs and YARA rules. I have a separate slide for that. And stability has highest priority, always. We've started here in Germany in the automotive and manufacturing sector with our first versions of THOR, and we always had a high priority on system stability, and therefore we have introduced many flags that I will explain later that can reduce system load, reduce the risk that a scan influences running services or influences system activity in a way that, for example, in a production line, we had systems that only had 512 megabytes of RAM and a single CPU core. So we designed THOR to be able to run even in these more difficult environments and more sensible environments. So other noteworthy features: archive scan, available in THOR Lite. So if you scan, for example, for the new CVE 2021-40444 vulnerabilities and want to find or match YARA rules in MS Office documents, it's also available in THOR Lite. So these rules would detect these malicious documents. You can, and that's also a great feature, you can include your own custom signatures and YARA rules in an encrypted form. There's a small utility called THOR Util that can be used to encrypt signatures with a public key of a private key that's in the THOR scanner, and so THOR would read the YARA rules in the custom signatures folder, decrypt them, initialize, compile them, and then use them during the scan. So the main reason for that, there are two main reasons for that. The first one is to not cause any false positives in other security systems, like when you move clear text IOCs around or clear text YARA rules around. This could cause matches in antivirus software, or could disturb a forensic analyst that later analyzes a disk image of a system on which THOR scan ran before, and therefore you can encrypt the signatures. The second reason for that is that you would hide the clear text information from spying eyes on that end system that could possibly be compromised and attackers working on the system. So you wouldn't want them to know what you're looking for. Second reason, also very important. Another really nice feature is the message enrichment. So every message gets enriched with more information. So if we, for example, in the professional version, if we use the shimcache module, and the only thing that we see in the shimcache module is the file name and path and SHA-1 hash, then we wouldn't just print these two values, but we would also evaluate all the other attributes that you would see also in file scan, like the owner of the file, the other hashes. We would try to find if that file is still on disk and indicate still available on disk, and then we would also scan that file and give some output to that. So we enrich even event log entries when you find a certain file name in an event log, then we would try to find that file on disk and add hash values to that THOR event. Although the original event log entry did not have any file hashes in it. So it really helps analysts later in the process to use or have all information available that we could evaluate on that end system at that moment during the scan. And they do not have to ask, please, dear administrator, could you give me the file that I can calculate a hash on it and check it on VirusTotal? All this information would be already available at the moment of his analysis. The most common use cases, obviously, the environment triage sweep. The second most often use case is a single system live forensics. So if something in your SOC, someone in your SOC tells you that there is a system with suspicious behavior, like contacted a known C2 domain. And what usually happens is that someone says, okay, what do we do now? How do we investigate what happened on this system? Based on log data that we have in our SIEM, yes, that's possible, but only to a certain extent. And in the past, you had to decide, do we just check this event and say, okay, we do not know what happened. It could have been something, but we would say it's most likely a false positive. So there is, and the other option would be to generate a disk image, collect a memory image of that system, and do a time-intensive forensic analysis. That could take half a day or day to complete. But with THOR Lite or with THOR, you could just bring that scanner to that end system, run a scan. This takes a few hours, but not a few hours of your forensic analyst's work. Time, sorry. And then after the scan, you could check the scan log and find out if there is really a reason to do a complete forensic analysis of that end system. So the third use case is image scan in lab, and the fourth use case is use it in drop zone mode in sample analysis pipeline. What is THOR Lite? I think you're most interested in the comparison. How compares THOR Lite to THOR? So there is also an open source scanner called Loki. I've developed that one years ago. It's not under frequent development. I just fix things from time to time, add some functionality that is that I would consider like critical to still call it cool, but yeah, it's something that I would do differently today, because we've moved from Python already in THOR, in older THOR versions, to Golang, to Go, and then I had all the it was just good at the time that I've developed it, but today I would recommend always using the THOR Lite version, unless you really care about open source, because THOR Lite is free, but it's not open source. So you have to register. It's just a registration for the newsletter that we send out like once, two times a year. It's nothing, and we do not have these typical marketing emails sent out to our users. So you register for that newsletter, and then you get an email with download links and a license, which is obviously free. The main and you get the scanner for Windows, Linux, and Mac OS already precompiled. You have x64-bit 64-bit versions and 32-bit versions of the scanner that you can run on older Windows or Linux versions. But the main difference between THOR Lite and THOR are the modules. Like the THOR Lite includes the most important modules, I would say, or some of the most important modules, like file scan, process connection analysis, and something that we have included. It's a project by Claudio that checks autoruns elements on Windows systems. It's also obviously in the free version. We also use PECIF, that's a project by Hesharizad, in the THOR Lite version. So you can activate process integrity checks during process scanning and get everything that PECIF produces also in THOR Lite. Another major difference is the YARA rule set. The THOR Lite uses the open source rule set that's located on GitHub in a repository named Signature Base. I would classify it as high quality YARA rule set that we use in our scanners. So it's maintained by us. We fix false positives from time to time. There are few, but there are some false positives that can appear with these rules. But the big rule set, the one with more than 60,000 rules, is only available in THOR. Nonetheless, THOR Lite is cool. It has all the features, especially in the THOR Util utility, and the output options are the same, just a bit limited coverage. But especially regarding all the exchange server exploitation, we have always I put a lot of effort in the detection rules for all the proxy logon exploitation, proxy shell exploitation, and proxy token exploitation in all scanners. So if you scan your exchange servers for detections of a compromise, then THOR Lite would also be very, very good. A good choice. IOCs and YARA. Which IOCs can I use in THOR? How can I use my own YARA rules? How can I use my own YARA rules? So there is a folder in THOR Lite, in the program folder, called Custom Signatures. You see it here on the right. And you can use many different IOCs. File hash IOCs, IPs, and full qualified domain names as C2 IOCs. You can also use mutex name pipes and events. Sorry, the checks for mutexes name pipes and events are also only available in the Pro version, and some keyword rules, like a certain service name that or scheduled task name that attackers have used. The more complex IOCs, I call them complex because we decided to do them as regular expressions, are the file name IOCs. The regular expressions allow us to write them very flexible. I have an example here. Maybe the example is that we, by looking for regular expressions, we could write rules that look for a single character executable file in the program data folder, or so the patterns that we can use are pretty flexible, and we are very successful with these patterns. For example, especially the ones looking in the program data folder directly in the program data folder for executables, VBS files, PowerShell files, as well as in the user's public folder, perflogs folders. There are some folders on a Windows system that are often used for staging, and we have generic detection rules for that. The YARA rules, they should be placed in the YARA subfolder of custom signatures. There are no special prerequisites. You can even drop the rules in different files. Other scanners, other appliances, and other products on the market that use YARA, they do not use YARA in an optimized way, but what we do is, when you place a lot of YARA files, YARA rule set files in that folder, we first combine all the rules, then compile them, and then apply them in a single matching invocation. So others create multiple rule sets and apply the rules from the different files in successively, or in the order in which they got initialized, and then this is not a good way to do that, because you lose a lot of CPU cycles. The Aho Cora 6 string matching algorithm cannot reach its full potential when you don't compile every YARA rule in a single rule set. Okay. Often used flags. Important. The question is, which of the 210 flags should I know? That's no joke. That's really no joke, but you will love it. We really have 210 different flags that you can use. Most often these flags are used to disable or enable a certain feature or module, but there are many flags, and there is, when you run THOR with -- help, you will get a help, and this help includes only the most important flags, and when you use full help, you get all flags that can be used in THOR to modify the scan. So which are the ones that you should know? The soft scan flag, often used on fragile systems in production lines, when you don't want to interfere with real-time services, for example, then you can use the soft mode, which reduces the scan speed automatically to not the scan speed, the CPU usage to 70%. It skips memory intensive checks, and it also skips checks that could possibly influence system stability. You should also know that soft mode gets automatically activated on systems with only one CPU core or less than 1 GB of RAM. So this can happen, and this happened often when users first did a trial of THOR and run it on their virtual machines, and they say, okay, this scan took longer than expected, and I tell them that it's most likely due to the single CPU core that virtual machine had assigned. So keep that in mind when you run scans. Limit CPU usage. You can limit the usage to a certain amount. It's often important, for example, on server systems, that to not trigger some operative monitoring alerts that tell you, oh, the system load on that system is over 90% over the last 30 minutes, and on workstations to reduce the fan noise level. Users, especially now when they're working from home, they do not want their fan running at highest speed, because that causes noise, and they say, well, let's check which process causes this noise, which process causes this high CPU load, and then they try to kill that process. And therefore, our customers often say, it's not that important that I get the result of that scan in 2 hours or 4 hours or 6 hours. It's more important that it does not interfere with system processes or with user experience, and therefore you could reduce the CPU load. It's also important for customers that have many virtual systems running on a single host, and if you scan a set of 20, 30 systems running on a single host, you don't want them all to use all CPU at the same time, and you can reduce the load on these systems by using that flag. There's a output redirection flag that you can use to redirect the output of every output file. So there can be many. Usually there are only two, the text log and the HTML report that gets generated at the end of the scan, but you can also generate a CSV file with all suspicious file findings and their hashes for later post-processing in other tools, and also JSON output files, for example, for a better import in your theme or log management solution of choice. So there are other output files that could be generated, and what we do with that flag is just redirect the output. So debugging, if you find, if you want to, for example, if you just want to test the single YARA rule that you have, and you want to test it on a folder in which the malware, the corresponding malware has been saved, then you can run THOR -a file scan to activate only the file scan module, and then point it with -p to that certain path, and check only that path, and test if your YARA rule would match on an end system. This sometimes is necessary to debug situations, and you can use the debug flag for that. And keep in mind, there is an interrupt menu when you see a scan running on a system and it takes very long, and you say, why is it taking so long? What's the current location, and on which folder is it? Which folder is currently processing? Let's see. I would like to see that. Then you can press Ctrl+C, and you will get into an interrupt menu where you see the last element that THOR is currently processing. And then you could continue the scan, you could skip the current module, or you could exit the scan at that moment from that menu. Right? Okay. Just one word about THOR Util. It's a small utility. You will find it in the program folder. You can use it to upgrade, and you should use it to upgrade and update THOR, especially the upgrade is used to upgrade program and signatures, and update is used to upgrade only the signatures. To update only the signatures, sorry. It can be used to convert output. Sometimes you collected only text logs and you would like to convert text logs from multiple systems to a single HTML report. That can be done with THOR Util. It could also be used for the signature and IOC encryption, as I told you, and to verify the signatures of the executables. So if you are unsure if the signatures are still correct, we have signature files located in the program folder with a .sig extension and executable files, and you can use this to verify that the integrity of the downloaded executables. Okay, but now let's get to how you can get THOR, how to download it, how to use it. Sorry for the long introduction, but I hope you appreciate the depth. It's not. I have a slide deck which takes 2 hours to go through. This was much shorter. Let's go to our homepage. On the homepage, there is the page of THOR Lite. You get some information on the scanner, and here on the download tab, you can download THOR Lite just by giving us an email address, first name, last name. We do not use this for marketing purposes, only to inform you about new features or things that we've changed in THOR Lite, and would like to inform you about them. So I really recommend using you don't have to use your business address, but you should use a valid address for that, especially because you get the download links to that address and information on the renewed license after 12 months. So when you register for that newsletter, then you would get immediately a license that runs for 12 months, and after 12 months we would send you to the same email address a new license for the new term, right, for the next year. So that's it. You get this, get the download links. Now I will make a cut and then go on with the live demo. Okay, so what I did was I downloaded THOR Lite. You get it as a zip archive. Then you bring it to the target system or extract it on your workstation. Run the THOR Lite utility, which is what I'm going to do in a few seconds. But I would also like to show you the directory structure. This is obsolete. You won't find this anymore. But there is a custom signatures folder with YARA where you can place your YARA rules, and IOC folders where you can place your IOC files. There's the docs folder, which only contains links today. There's a log analysis manual that can help you or help your analysts with the analysis of the THOR logs. And there is the manual for THOR and the THOR Util, which are just links to an online manual. We had that in the past as PDF documents, but it turned out to be not as usable and not as flexible as we would have liked it to be. It's much easier to fix bugs or fix errors, typos in an online version, and add new content, add a feature that's missing in the PDF. Later it's not possible, so we had to update the PDF versions with each update, and the file was like 5 megabytes in size. So the online version is much more comfortable, and you can access it from anywhere. It's not somehow restricted. You don't have to use a username or password to access it. Okay. One important note: consider that the chapter before you begin. Just read it and see. There are some important tips that can help you with the deployment. Okay, but let's go to the program folder. You see there is the 64-bit version and the 32-bit version here, and there is the THOR Lite utility. What I will do is I will open up Windows command line in this case as administrator. I will move to that THOR Lite, yeah, to that folder, and then I will run the THOR Lite utility once to get a new THOR Lite version and new signatures. It's because the THOR Lite that I had on this system was a bit older, I think. Yeah, we've just upgraded THOR from version from 10.6.8 to 10.6.10. So 2 bug fix versions, and we've also upgraded the signatures. You can see that down here. Okay. THOR Lite. With help, you get the normal help as I told you, and with, it says here, with full help, you will get the full help with all command line flags. But the help already contains the most important ones, which already could appear a bit overwhelming, but believe me, when you start doing compromise assessments with a tool like THOR, you will sooner or later need a lot of adjustments. We can look at them. For example, there is what do we have? We can define the output location for every file. We can send syslogs to certain target systems, to ports, and in certain protocols, UDP, TCP, TCP, TLS, and so on. So we have a reason for every flag, and the normal help also includes these usage examples down here. So could also start or already start scanning when you look at it. And what I will do is I will just run a THOR scan. What people ask me very often is, which flags should I use? Which are the recommended flags? And what I usually answer is that they should just run the THOR scan. If there is something that we recommend to use, then we would already have been made it the default. So everything that you can enable or disable with flags is what we wouldn't recommend. No, it's not the default due to a reason. So there is a reason that certain commands are not the default. For example, the intents flag. Users that read the flags before scanning, they often use the intents flag because they say, well, I want an intent scan, but the intents flag, you can look it up in the manual. Everything is explained there. The intents scan mode will also disable a lot of safeguards. It will scan every file, not only the files that have been cleverly pre-selected. So the scan time will be much longer. Then it will scan also file types that are not considered interesting. So we do not recommend intent scan, except in labs where you have an image of an end system and you have a powerful forensic workstation that can process that, and you have no stability issues on that system, obviously. So there, the intents flag makes sense, but in the field, while scanning live systems, you shouldn't use the intents flag. Yes, but what I will do is I will just start a THOR scan. You will see that it initializes the signatures up here in this section, and then it already queries locations with auto start elements. You see a lot of green here and maybe some blue entries. The green ones are the info level messages, so only they have informational character. The notices are the ones that you can look at when you have a lot of time and want to really dig into that system and understand, find everything that is slightly suspicious. Then you look at the notices. But in most cases, you would only look at the warnings and the alert messages, which are yellow and red in the command line and in the HTML report. The scanner now also has down here this progress bar. You see there's one worker working at this process. There is multi-threaded scanning, but only in the Pro version, not in the THOR Lite version. Sorry for that. So we only have one worker here scanning all the processes, and while it is scanning the processes, it scans the process memory, it analyzes process connections, and also handles of that process for file name IOCs, for example. So we do not only apply file name IOCs during the file scan on disk, but we apply this file name IOCs in every possible module. So we apply file name IOCs, for example, also in log scanning. When we scan web server logs, other logs of an IIS web server, for example, then we would also find a web shell called shell ASPX in the log files, although the attackers may have already deleted it in the file system. Also in MFT, in the MFT module or other modules. We apply the IOCs in every location possible. So that's something that also distinguishes us from other products. Okay, our scanners from other products. Now, he's still working on the processes on that system. There are some. I could show you the interrupt menu. At that moment, we will see last scanned element, worker 1, active module process check. Element is process ID 1948. I can instruct him to continue, and he would continue the scan at that moment. What else can I tell you while the scan is running? There is a log file that appears shortly after the scan started. You can open it. Can I use the hex editor? Maybe it's already 8 users left. So we can open up the log file and you will see all the information on the system. There is always reload, yes. There is a section up here which includes a lot of information about the end system. Let me make it a bit bigger for you. This is important. First, you may think, well, why is that so important? There's no thread in here. But when you use THOR on hundreds and thousands of end systems, and you collect the logs, it's so important in the end to get a good overview on which systems did we scan, and also the information, what kind of system was this? Was this a Windows 2008 R2 server or a Windows workstation? In which time zone? To which time zone was it set to? Which language did it use? So that you can relate this scan report to a certain subsidiary in a different country, for example, and so on. So the information up here can also give you a good, when you process it and do some analysis on it, it can give you a good asset overview. I tell you that because many of our customers did not have a good asset overview when they started to use the scanner, and then after that they at least had a good overview on the systems that they were able to scan. But let's get back to the scan. We see that THOR is already scanning the file system, and we see that he produced some warnings here. One of the warnings is visible. That's possibly dangerous file found in the perf logs folder p.exe. This is one of the examples that I showed you in one of the slides. Like there is something, what is it? And now you see here, down here, you get the enriched information. It's not just pattern file name pattern match on a certain file. You get the information on the file. It's a sysinternals file. It is sysinternals execute processes remotely. It's most likely a psexec renamed to p.exe. Let me see if I can scroll up while it's running. There are some files in the recycle bin. Most likely someone scanned, moved the reports to the recycle bin and then didn't empty it. That happens all the time. So old THOR reports on that system get moved to the recycle bin, and then THOR finds strings in these reports in the recycle bin. Happens. Difficult to avoid without problems, possible issues that could appear. Here's a link to one PHP web shell that was used on that system. You see that there's a file name match, custom IOC 1.php here in the recents folder. So the file name matched on this file. Let's end that scan here. Exit. Oh, I will cancel the current module with X. And the scan finished because this was the last module. And after the scan we get this HTML report. I say allow block content. Don't do that on every file, but the content in here is JavaScript content that we use to help you work with these HTML reports. You can see there are many reports here. Someone has deleted that reports and now they are in the recycle bin. What I can do now is I can select this and say filter out, and then every event with that string in it would be filtered out of my view. So I can see down here that it has filtered 22 elements, so 22 reports in the recycle bin. And now we only see the remaining warnings and alerts. So there are no alerts, but we see a warning number 3. And this is an NTDS zip file in the perflogs folder. There is a rule that says suspicious zipped NTDS did file. So there is a YARA rule that detects this NTDS, this zipped compressed NTDS file in the perflogs folder. It's not related to the perflogs folder, but only the zipped NTDS did file. And there we have the psexec that we've already seen, the one PHP, and another report that's still in the documents folder. There are more notices down here that you could look through, but normally you should only look at the alerts and warning messages. So that's it for today. I will produce more videos on certain features, maybe when we have another proxy logon, proxy shell, proxy token thing, and I wrote new signatures, then I would show you a scan run on one of our Exchange servers that we use in research to test some exploits on them, to give you a tutorial on how to write YARA rules or file name IOCs for these compromises that may be specific in your case. So you have certain indicators of compromise that no one else has and would like to use them in a THOR scan. I think this could be one of my next videos. So stay tuned. I hope you liked it. See you the next time. Bye and have a nice weekend.